Hi there, I'm Paul Belflam and this is Industrial Organization. This presentation is about price competition. We want to analyze price competition in a duopoly when firms produce either differentiated or homogeneous products, and this is based on the following parts of the textbook. Okay, so remember in a previous presentation we've introduced a unified model with the aim to be able to compare price and quantity competition, and we do so in a simple duopoly framework where we've got firm 1 producing good 1 at some constant marginal cost C1 and firm 2 producing good 2 at some constant marginal cost C2. As has been shown before, this can be generalized to more than 2 goods, but this is all we need now to understand how firms compete in prices. In a next presentation, we'll look at the competition in quantities. Okay, so remember this is the maximization program of firm 1 in this specific model. To simplify it a little bit, our computations, we will set b is equal to 1, meaning that d can take any value between 0 and 1. Just to recall what d means, this is a measure of the substitutability between the products. When d is equal to 0, products are totally differentiated, and when d is equal to 1, the products are exactly the same. Okay, but remember the demand function, which is defined here, Q1 of P1, P2, is not defined in the case where d is equal to 1, when the goods are exactly the same. So we'll have to treat the case of homogeneous goods in a separate model. Okay, so for now we assume that d is strictly less than 1, and with b is equal to 1, this is here the maximization program firm 1. Okay, so this is what we want to analyze now. Right, so firm 1 is choosing its price to maximize its profit, which is written in this way. This is a continuous game, remember the definition. It's a game where actually the strategy sets, the strategy that the firms can choose can be any number between two boundaries, and here a price can be anything between 0 and, in theory, plus infinity. Okay, and so the important thing with continuous games is that when we look for the best response function of a firm, we can use calculus. Okay, so this is what we do here, the first order condition for profit maximization, which is simply that the first order condition with respect to price being the choice of the firm here, this first order derivative must be equal to 0. Okay, which is to say that the marginal profit should be equal to 0. Okay, and as we will show, this is how you can derive the best response function of the firm. So let's do this. This is if you look at the profit here, this is a product of two functions of P1. Okay, well, the 1 over 1 minus delta square doesn't appear here. I've skipped one step. We have already multiplied everything by 1 minus delta square. Okay, as the right-hand side is equal to 0, here it doesn't change, but that's why the 1 over 1 minus delta square doesn't appear here. Okay, this being said, let's come back to the product of two functions. You know that the chain rule to take the derivative, it's the derivative of the first function, here 1, that multiplies the second, this is what we have here, plus the derivative of the second function, which is minus 1, which we multiply by the first. So that's why you've got a minus P1 minus C1. Okay, now what we need to do is to isolate P1, which we take on the left hand side, and so we have 2P1, we divide through by 2, and on the right hand side we have what we called R1 of P2. This is the best response of firm 1. Okay, remember what that means? It means here this is the best strategy that firm 1 should choose for any given strategy of the other firm. Okay, so in this case, strategies are prices, so the best response function of firm 1 tells firm 1 which price P1 it should choose to maximize its profit for any price P2 that firm 2 could choose. Okay, now the important thing to note here is that this best response function is upward sloping. The slope is positive. Okay, so if you take the derivative of R1 with respect to P2, you find it is equal to d over 2, which is positive. Okay, so in economic terms, it means that if firm 1 imagines that firm 2 is going to set a higher price, then the best reaction of firm 1 is also to raise its price. Okay, so another way to say this is to say that the prices, the decisions of the two firms in this game, the prices are called strategic complements. Okay, why? Because they mutually reinforce one another. Okay, roughly said, they go in the same direction. If P2 is expected to increase, firm 1 reacts by increasing P1. Okay, in more technical terms, if you assume that firm 2 would increase its price, then we see that the marginal profit of firm 1 increases. Okay, the marginal profit of firm 1 is this derivative here. It's the sensitivity of the profit of firm 1 to its own price. Okay, and recall that the price here is the strategic decision of the firm. Okay, so the marginal profit of firm 1 is this, and we want to know how it changes if P2 changes. Okay, so this is the chain of derivatives, which we can write in this way as well. This is a cross second order derivative. Okay, and if you go back to the profit function and do the math, you find that this derivative is equal to d over 1 minus d squared, which is positive. Okay, so this is the mathematical confirmation of what we are saying here and here. The marginal profit of firm 1 increases when firm 2 increases its price, and this is why we say that we have strategic complements. The two strategies reinforce one another. Okay, now the intuition is very clear. Imagine that you're competing with another firm and you expect this other firm to raise its price. So the product of the other firm becomes more expensive. Okay, now the consumers are more interested in your product in that case. Okay, because the other product becomes more expensive, so they will, some of them at least, will turn to your product. Okay, so you will have more consumers, and then it becomes more profitable for you at the margin to raise your own price. Okay, so that's the idea. And again, this is equivalent to say that the best response function is upward sloping, as is shown on this graph. Okay, so P2 is on the horizontal axis, P1 on the vertical axis. I want to express P1 as a function of P2. Remember, this is the idea of this best response. How should firm 1 choose its price to maximize its profit given the price of firm 2? Okay, and we see if we just draw the reaction function that was given on the previous slide, you have this line here which has a positive slope. Okay, now it's interesting to ask how this best response function evolve if the parameter d changes. Okay, so if we have a decrease in d, it would mean that the products become more differentiated, more different from one another, and we know that at the limit, when d is equal to 0, the two products are totally independent of one another. Okay, remember we qualified the situation of local monopolies. Okay, so there we would expect at the limit when d is equal to 0 that the firms don't care at all about one another. Okay, each firm sets its price without caring about the other firm. Okay, so let's check if this is what we obtain. So here I've drawn in red the reaction function for a value of d which is lower than d1, and you see that the slope is of course also less steep. Okay, and at the limit, when d is equal to 0, we've got a horizontal reaction function. So this means that whatever the value of P2, the value of P1 is always the same. Firm 1 chooses the same P1, whatever the price chosen by firm 2, which is to say that it doesn't care at all about what firm 2 is doing, which makes sense because in that case, when d is equal to 0, the products are completely different from one another. Basically, this is the monopoly situation. Okay, so we just record this lesson here. The small d, which means the more products are differentiated, the less the strategy of one firm is sensitive to a change in the strategy of the other firm. Right, so important notions here in price competition with two firms producing substitutable products, the prices are strategic complements because they mutually reinforce one another, and this is synonymous to say that the reaction functions, the best response functions, have a slope which is positive. Okay, so let's move now to the Nash equilibrium. Okay, so you can redo the previous analysis to find in an exact similar way the reaction function of firm 2. Do this on your own, just to check whether you've understood correctly the process. Okay, and now the rest, if you want to find the Nash equilibrium, you remember the definition. It's a combination of prices such that both firms best respond to one another. Okay, so this is what is written here in mathematical forms. It's a vector of prices, P1 star, P2 star, such that P1 star is the best reaction to P2 star, and at the same time, P2 star is the best reaction to P1 star. Okay, so on the graph, we will see this on the next slide. This is the intersection of the best response function. From an analytical point of view, this is the solution to the system of two equations in two unknowns, which is comprised of the two reaction functions. Okay, so this is actually what we do here. We substitute in the reaction function of firm 1 the reaction function of firm 2. Okay, so you can go back a few slides if you want to see the reaction function of firm 1. I've just cross-multiplied by 2, and I replace P2 by the value I have here. Okay, so I'm looking for the solution of this system, and you can review the next steps at your own pace to find out the equilibrium price of firm 1, and you can substitute then in the reaction of firm 2 to find the optimal price, the equilibrium price of firm 2. Okay, let's note in passing that quite logically the two prices increase with the two costs. Okay, if it's clear for firm 1, if it has a larger cost, it will have to set a larger price. Okay, but because we have seen that the prices are strategic complements, the price at equilibrium of firm 1 also increases with the cost of firm 2. Why? Because when firm 2 has a higher cost, firm 2 will set a higher price, and if firm 2 sets a higher price, the best reaction of firm 1 is to set a higher price as well. Okay? This is the confirmation from a graphical point of view. What we have done here is to superimpose the reaction function of firm 1 and the reaction function of firm 2. For firm 2, it's just a mirror image of firm 1. Okay, and the black case here corresponds to a high value of D. And remember, if we decrease D, we are going to change the slope of these reaction functions. So sorry, I was wrong with what I said. This is the largest value of D. This is a smaller value of D. This is when D is equal to 0. Okay, then looking at the intersection of the two reaction functions, we've got the equilibrium prices. This corresponds to the three cases, three different values of these. And what we find is that the equilibrium prices, they decrease as D is increasing. Okay, in economic terms, this is all again quite easy to understand. When D increases, this means that the products become more closer to one another and more substitutable, so that increases the intensity of competition and drives the firms at equilibrium to set lower prices. Okay, more competition here through products which are more substitutable, more competition leads to lower prices at equilibrium. Okay, so let's use the same model now to look at what happens when firms are symmetric, and we mean by that they have exactly the same cost. Okay, so what you have on this slide is just taking the previous expressions but setting C1 equal to C2 is equal to C. Okay, as firms are symmetric, they will set the same price at equilibrium, have the same quantity, and make the same profit. Okay, I'll let you redo these different steps on your own. We will just keep this in mind because later in the course next week we will compare the outcome of price and quantity competition. And so we keep in mind that the profit of the two firms when they are symmetric in the price competition case is given by this expression here. And just to check what we had on the previous slide, we see that if we increase D, we've got a profit that is decreasing. Okay, so D is equal to 0 corresponds to the benchmark of the monopoly. And when D is going to 1, recall that we cannot analyze the case D is equal to 1 in this specific example. We will do so in the next slide, but we also see that the profit is going to 0. Okay, so let's analyze properly now the case when D is equal to 1. And this is a model you already know. This is a standard Bertrand model named after Joseph Bertrand. So it's as before, there are two firms. The difference is that now we consider homogeneous products. They produce exactly the same product. The result, the consequence of that is that the consumers just care about the price, as we will see in the demand function. Okay, we focus on the case here when they have the same cost. Okay, but the game is as before, they set their price at the same time, so they cannot observe the price of the other firm when they set their own price. Okay, now consumers, we need to be specific about how to formulate the demand. The firm with the lower price will attract all the demands. So if this price is P, the total demand will be Q of P. We just need to specify what happens when the firms set exactly the same price, and we assume that the market splits somehow. A share alpha 1 of consumers will go to firm 1, and the complementary share alpha 2, 1 minus alpha 1, will go to firm 2. Okay, and so the demand for firm I, so the quantity demanded to firm I when it sets a price Pi, is the whole demand if Pi is lower than Pj, so if firm I is less expensive than firm J. It's 0 if firm I is more expensive than firm J. And it's this share alpha I of the total demand if both firms have the same price. Okay, so as we already explained before, there is a discontinuity here at the level where prices are the same. By changing a little bit your price, you go from basically no consumer to half of the consumer or a share of the consumer, and then by lowering a little bit your price more, you get the whole demand. Okay, so there is a discontinuity here that we didn't have in the previous case when the goods were differentiated. Okay, now you already have covered this model, so let me just remind you of the result, which is that the only Nash equilibrium is that both firms will set a price equal to marginal cost. P1 is equal to P2 is equal to C. You can check, this is another way to find out a Nash equilibrium. You can check that for any other pair of prices, there will be a profitable deviation. So one firm will find it profitable to change its price given the price of the other. And if one firm has an incentive to change its price, then we don't have a Nash equilibrium, because it would mean that the initial situation was such that one firm was not best responding to the price of the other firm. Okay? If you apply the same method as before, you can build up the reaction function of the two firms and find out that the only intersection is at this point here where price of firm 2 and price of firm 1 are equal to the marginal cost. Okay, so let's just pause a little bit here to explain how this reaction function is built. Well, what is quite intuitive is that imagine I'm firm 1, okay, and I'm trying to see what is best for me given any price of the other firm, any P2. Okay, I know that if I'm less expensive than the other firm, I can get the whole market. Okay, and if I get the whole market, I prefer to have a high price, the highest possible price. Okay, so it suffices for me to have a price just below the price of the other firm. Okay, so I want to be here just below the 45-degree line, having a P1 which is just below P2. Okay, that is enough for me to gain the whole market and to maximize my profit. Now, there are two reasons why I don't want to do that. I don't want to go below my costs. Okay, so if I set a P1 below C, I would make losses. Okay, so if P2 is below C, I'm not going to follow and set a price below P2. I just stop here. I don't want to make losses. Okay, and here I don't want to go above the monopoly price. I mean, if I get the whole market for myself, I know that if I set a price above the monopoly price, I would make a lower profit. Okay, I would stop where at the price that maximizes my profit when I get the whole market. So here I've got this other part which is horizontal. If I have a price P1 which is less than P2, which is the case here, I have no reason to go above PM, which is the monopoly price. Okay, so this is the reaction function of firm 1. If you do the same analysis for firm 2, this is how the reaction function of firm 2 looks like. And when you cross them, you see that the only intersection is here, which is the result we have established. Price is equal to marginal cost. Right? So let us just finish by saying that this has been called the Bertrand paradox. Okay, why? Because when you look at the situation, there are only two firms, and so you should expect them to have market powers, to have the possibility to raise prices above marginal cost. Okay, but in this simple model, with the assumptions we've made, mainly that the products are homogeneous, but also implicitly, it hasn't been said, but we also assume that firms have an unlimited capacity. So if all consumers are coming to them, they are able to serve them. Okay, so that's another important assumption. And also, we haven't said this explicitly, but it is assumed that the consumers can observe both prices without any problem. So the market is transparent. Okay, so this is an important condition to justify this demand function that we have, that consumers buy where the price is the smallest. Okay, so under all these assumptions, we have this kind of paradoxical result that although there are only two firms, they don't have market power at equilibrium. The prices go down to marginal cost, which is exactly what you would have if there was a large number of small firms in the industry. So if the market was perfectly competitive. Okay, so we will have a lot of opportunities to discuss this and to relax one by one the assumptions of the Bertrand model. But the message we need to keep here is that there are circumstances where even duopoly can lead to extreme competitive pressure. Okay, and this is certainly the case when the products are very alike, when they are not differentiated. Okay, so this has been called, we will see this on the next slide, this has been called a commodity, a product that is exactly the same from many firms. This is called a commodity. We'll see this on the next slide, but before that, let's just extend a little bit the model by seeing what happens when there are more than two firms and when they have different costs. So consider n firms and rank them by increasing costs. Okay, so Ci is less than Ci plus 1, meaning that firm 1 in this case is the one with the lowest marginal costs. Okay, so as you may guess, this firm has an advantage. It can lower the price more than the other firms can do because it has a lower cost. And so it will set its price above its own cost, okay, but below the cost of the next efficient firm, which is firm 2 here, okay. All firms will actually set that price at equilibrium, but only firm 1 will sell to consumers. The other firms would sell zero, otherwise they would make losses, and this wouldn't be an equilibrium. Okay, so I'm very quick here, but it also means that even if firms are more than two and they have different costs, we have a result which is almost similar to what we have here. It's still a paradox because most of the firms don't get any profit and don't get any market power. Okay, just to finish, I will let you read this at your own pace, but this is a message which is given to firms. So this is a paper coming from Roland Berger, which is one of the large consulting companies, and basically what they tell to the companies they are advising is that be careful of not letting your product become a commodity, and they define a commodity as what we call a homogeneous product. There is a high level of standardization, there are many comparable substitutable products, and there is price transparency on the market. And so because of that, there is what they call a commodity trap, meaning that the situation is such that the price margin, the prices are low, the margins are very low. Okay, and so we will discuss this in a few weeks, but a natural response to this is to try and make the products differentiated to relax this price competition. But this will come in the next presentation. For now, this is all we wanted to discuss.